in this video, we will learn how to graph quadratic functions. A quadratic function is a function of second degree, such as the following: f of x equals x minus 3 squared minus 2. To make the graphing simple and easy, we have to identify the value of the vertex. We can identify the value of the vertex of a function if the function is in the vertex form. The vertex form is f of x equals a minus x minus h squared plus k. So in this particular example, this is the value of your h. So here h is 3, positive 3. And here the value of k is negative 2. So our vertex is at 3, negative 2. Now that we have the vertex, we are ready to form the table of values. So the table of values will consist of x and f of x. And I recommend that we put 5 different values for x so that we can see clearly the graph of the function. So we need to form 5 columns. So 1, 2, 3, 4, 5. And then always remember to put the vertex in the middle of the table, the middlemost column. So we put h here and then k here. So in this particular example, h is 3 and k is minus 2. Then what we need to do is to fill these x values with the consecutive numbers. Our basis will be 3. So after 3 we have 4, then we have 5. Here we have 2 and then 1. After that, we will evaluate the function at these values of x. Okay. Now, for example, let's find the value of f of 1. So to evaluate a function means you're going to change or replace the value of x with this value here. So 1 minus 3 squared, okay, minus 2. We will use the original function for this one. 1 minus 3 is negative 2. So negative 2 squared minus 2. Negative 2 squared is 4. Then 4 minus 2 is 2. So the value of f of 1 is 2. We will input 2 here. Then the next one is f of 2. So again, 2 minus 3 squared minus 2 equals 2 minus 3 is negative 1. Negative 1 squared minus 2 is, well, negative 1 squared is positive 1. Positive 1 minus 2 is negative 1. So we put negative 1 here. Now the reason why we put the vertex at the very middle of the table is so we can reflect the values of f of x from this side to this side. That means the value of f of 4 will also be negative 1, and the value of f of 5 will also be positive 2. There. So by doing that, we minimize the number of work or the number of computation that is required for us to graph. Okay? So we will know that f of 4 is negative 1 and f of 5 is 2. You can verify this by evaluating the function at x equals 4 and x equals 5. Now after this, the most important thing that you should know is these are the values in this table of value will form the ordered pairs. Okay? So we have 5 ordered pairs here. The ordered pairs are 1, 2, 2, negative 1, 3, negative 2, 4, negative 1, and 5, 2. These are the values, or these are the points that will determine our graph. Here I have the Cartesian plane, and we're going to plot the points that we just determined a while ago. So the points that we determined a while ago are the following. We have 1, 2. We have 2, negative 1. the vertex, which is 3, negative 2, the other point being 4, negative 1, and 5, 2. So first, we will plot these points starting with the vertex. So the vertex is 2, negative 3. No, 3, negative 2, I should say. 3, negative 2 is located here. And then we have 1, 2. 1, 2 is located here. And then we have 2, negative 1 is located here. Then we have 4, negative 1 located here. And then 5, 2 located here. So now that we have the plot of the points, we can now draw our parabola. By the way, parabola is the name or the name of the graph of a quadratic function. So in this case, we just connect the dots using a smooth curve. Just like that. So this is the graph of the function f of x equals x minus 3 squared minus 2. And that's how you graph a quadratic function. Let's have another example. So let's say the function is not written in the vertex form. Instead, it's written in the standard form. So the standard form is, for example, x squared plus 4x plus 6. So this is the standard form of the function. So we need to transform this function into the vertex form first. And we do that by completing the squares. So f of x equals, the first one is to isolate these two. So we get x squared plus 4x. We need to leave a space here plus 6. The space here for completing the square will be half of 4. So we take 4, we divide it by 2, we get 2. Then we square 2, we get 4. So we need to add 4 here and subtract 4 here to make the equation the same. And then we complete the square. So f of x now will be equal to x plus half of 4, or the square root of 4 is 2. So we put 2 here squared. Then 6 minus 4 is 2. After that, remember that this is your h. The value of h is here. But this is positive, so we change the sign of that. We get h equals negative 2. Then here, k equals 2. So the vertex is at negative 2, 2. Now that we have the vertex, it's time for us to determine the table of values. X, f of x. Again, we use 5. So 1, 2, 3, 4, 5. We put the vertex at the very middle of the table, so this will be negative 2, k will be 2. And then we complete the table with the natural order of the integers here. So to the right of negative 2 is negative 1, then after that 0. To the left of negative 2 is negative 3, then negative 4. Now since we know that we are just reflecting the values of the numbers here in f of x, we choose the easier number to evaluate. So we choose 0 and negative 1. So we evaluate f of 0 first. So f of 0 will be equal to, we can use either the original function, its standard form, or we can use the vertex form. Personally, I want to use the vertex form because it's easier. So 0 plus 2 squared plus 2. 0 plus 2 is 2. So we'll get 2 squared plus 2. And 2 squared is 4. 4 plus 2 is 6. So the value of f of 0 is 6. Then that means the value of f of negative 4 is also 6. Because remember, we're just reflecting these two values here. Then we have f of negative 1. So we have negative 1 plus 2 squared plus 2. Negative 1 plus 2 is 1. So we have 1 squared plus 2. 1 squared is 1. 1 plus 2 is 3. So the value of f of negative 1 is 3, which means the value of f of negative 3 is also 3, because that is just reflection here. So now we have the 5 points. We have negative 4, 6. Then we have negative 3, 3. We have the vertex negative 2, 2. And the other points negative 1, 3. And 0, 6. So we need these points to graph our function. So here again, the points that we determined are the following. So we have negative 4, 6. And then we have negative 3, 3. The vertex, which is negative 2, 2. The other points, negative 1, 3. And 0, 6. So we plot the vertex first. So negative 2, 2 is up here in the second quadrant. So negative 2, 2 is here. And then we have negative 4, or let's start with negative 3, 3. So negative 3, 3 will be somewhere here. And then we have negative 1, 3 is here. 0, 6 is here. And then negative 4, 6 is here. There. Now that we are done plotting the points, we are now ready to connect these points using a smooth curve. Just connect the point like that. And there you have it. You have the graph of your function. So this function is f of x equals x squared plus 4x plus 6. That's it. That's how you graph a quadratic function.